All right, this next section deals with inequalities. Chapter 4, Section 5. Polynomial and rational inequalities. First off, let's look at polynomial inequalities. Yes. Here's how eventually we want to start off this way. Whatever our inequality is, we have to set it equal to 0 and then solve it from there. Why is that? Because if we looked at it as some number equals less than 1, how many ways can you equal 1 in an equation? Many ways. It's 4 minus 3, 5 minus 4, 6 minus. So if you set it equals 0, there's only one 0. So that's why whatever you have in your polynomials or inequality or your rationals, set them equal to 0, one side. In other words, move everything over to one side. Negative. Let's look at that one. There's your polynomial. The first thing you have to do is set it equal to one side. Treat it like an equal sign. But here, what we're looking at now is we only want the part of the graph that is, since it's less than, below the x-axis. Since it's less than. If it was greater than, then we want what's above the x-axis. So that's why setting it to 0 is important. Factor out your equation if possible. They're both the same. They're both plus. What times what is 3? When you add them, you get 4. 3 and 1. So first step is factor. Find the x-intercepts. So my x-intercepts are where? So these. Since it's a parabola, does it open up or down? So we know that this graph is going to look something like this. And at -2, it'll be the vertex somewhere. So at this point, we don't have to go any further. We don't need the rest of the graph because since we know the end behavior, we only want the part of the graph that's below the x-axis. So our solution is that. This is the domain where our function is less than 0. That's what we're looking for.
So why is it different from, maybe I'm misunderstanding. Like if you have a line, don't you like shade all under the line? Or two lines?
Well, yeah, it's we have now have y value. So say what this is looking for again, we set that equal to 0. What we have is we have this line. And then it all depends. Set this equal to 0. We only want the part of the graph that's above the 0. So we pick a point. Let's pick a point here. At 1, 1. Plug them back into our original equation. So it's 1, 1 plus 3. Is 1 less than 4? Yeah, so since that's true, all of these are your solutions. Now, I'm only looking for a domain because all of this I'm looking for here is this, where the function is below the x-axis. It's similar to it, but we're more restrictive now. I'm glad you asked that. It's a very good question because with linear equations, it's either going to be one side or the other side of the line. Let's look at this equation. First step is always set it equal to 0. So we subtract x squared from both sides. And add 1. So 5x minus 5 is greater than or equal to 0. Then what? Add 5, yeah. Since we're, yeah. So 5x is greater than or equal to 5. So we know our domain here is x, anywhere x is greater than 1. That's all there is to it. Yes.
Let's say, for example, delta like greater than or equal to make a difference.
Mm-mm. Yeah. Well, greater than what's actually, I'm like, yes, there is now, because if we were to graph this, we'd start off with a solid dot and everything there. So it would be 1 to infinity. If it didn't have that equal sign, then it'd be a parenthesis and it'd be an open circle. Or if we had, let's go back to this one. This is a linear equation. So it's y-intercept is 3 and then 1 over 1. Since it's an equal to, it's a solid line. If it was like this, then it would be a broken line. Because we cannot use the points on that line. This one, we can use the points on that. And then we pick a point that's not on the graph, 1, 1, plug it in there. Is 1 greater than 4? Nope, so it's over here. So yeah, the only difference is the line you draw. With linear equations, it's pretty easy. With quadratic equations or higher order polynomials, it all depends on what the factored form is. Because you have to see how many intercepts you have. In other words, if we had this polynomial. And the question, if it was written in a question, it said, find where the polynomial is less than or equal to 0. I'd give you P of X is equal to this polynomial. So you'd set it up this way. How would you factor it? Grouping. We'll try grouping first because it's a cubic function. What is grouping? Take the first two, put them in parentheses, and the last two, put them in parentheses. What can you factor out of the first one? X squared. They both have two x's. If you divide both of these by x squared now, that tells you what goes inside there. So we have x minus 2. Let's make it a minus. No, leave it as a plus. What can we factor? Anything? No. So that's the first step. Now we can factor out an x minus 2. Anything, the coefficient, anything left goes inside the second one. Now you'd graph this one. Let's see, where are my x-intercepts? This is imaginary, so it's just 2. So we have an x-intercept there. Now we plot some points. What does the graph look like? Does it have a y-intercept? At -2, the constant. So that's all the x and y's that we have. We plot some points. We know on this side, since there's no more x-intercepts, is the graph ever going to be above the x-axis again? No. So we know this side, the graph will do something like go down, or may have some funky curve. What happens on the other side of this intercept? Does it bounce down or does it cross and go through the side? Let's find out. 3 minus 2 is 1. 3 squared is 9 plus 1 is 10. So this one is 10. So it goes all the way up here. So our only solution is from -infinity to -2. We're interested in where's the graph below the x-axis. Yeah, but again, that's why you have to have a 0 on one side, because it's either above or below the x-axis. Let's think of the one of the ones we just did. If y equals if y equals that, I want, bless you. I want to know where the graph is below the x-axis. So what would you do? Factor the top and same thing we did last time. This is the equation I'm using. Do exactly the same thing we did last time. It was zeros on one side. We just have to fix this side. We get our graph that will look like this. And its horizontal is there. So we have a negative there. This one's at 2. So what would our answer be? No.
No.
I want to know where it's below the
Oh,
x-axis.
below. -2 to -1.
To negative, because that's the asymptote. It's -1.
Two.
Can I include -2? Because I can't include that point. It's an equal sign.
Oh, okay.
So in other words, I can see where it's, so this one is 2 to 4.
Oh, below.
Right. Yeah, don't get mixed up with the horizontal asymptote. It's the x-axis we're looking for. So that's what the process is. That's why we learn how to factor out the rational polynomials first, because we need to know that to be able to draw the graph so we can find inequalities. What if you had that? Is that? Yep. Because you have to have a 0. So it's 1 over x plus 3 minus 4 is less than equal to 0. Then what?
Four is-
Was that?
4 would be, or -4 would be right. No? You have to have a common denominator.
Yep. You have to simplify the equation. So we need to have x plus 3 over x plus 3. So it's 1 over x plus 3 minus 4 times x plus 3 over x plus 3 less than equal to 0. One minus, well, let's do this step by step. Because this one's going to be a -4 distributed. So it's 1 minus 4x minus 12. So it's -4x minus 11, x plus 3. Now we have it set up. Then what do you do?
Were these?
No, they're my algebra, but if you want to take them, you can take them. On the other side, it's the transformations and symmetry things we did in chapter 2. But yeah, you're more than welcome to if you want them. So we have to find the horizontal asymptote, the vertical asymptote, the x-intercept, and the y-intercept. So what's the horizontal asymptote? What's that?
Negative.
Yeah, because both of the leading terms have exponent of 1. They're both the same. What's the vertical asymptote? Yeah, set the bottom equal to 0. What's the x-intercept? Take the top, set it equal to 0. Negative 11. Change the sign. And then divide by 4. And the y-intercept? The y-intercept, set all the x's equal to 0, just whatever the constant are. So we have negative 11 over 3. So the horizontal asymptote is at negative 4. Vertical asymptote is at negative 3. X-intercept is at negative 11 over 4, which makes it negative 2 3/4. The y-intercept is negative 3 2/3. All right, so our graph here will look something like that. That means this side here will look like that. We want to know everything less than 0. So what's our domain? Let me see. This one is at negative 3. Can we include negative 3? No, because it's an asymptote.
Oh,
Union.
negative.
Well, actually, it's from this intercept, not negative 3. It's the
Oh.
x-intercept, negative 2/3. Negative 2 3/4 to infinity. Because it's where that intercept is. It's the same process. So we have to treat it in 2 steps. Is you have to first graph the function, say it equals 0 and graph it, and then look whether it's above or below the x-axis. That's all you're looking for. What do y'all think? Understandable? I confuse y'all? I'm looking at a bunch of faces there, like waiting for the train to hit y'all. When we do some more examples, are you okay? It takes I can't let you, it's gonna take practice because you have to factor it, you have to make sure you set it equal to 0. Get a common denominator instead of just saying negative 4. All right, so we'll call it a day there. It's the negative 2 3/4. This is the domain, yes, negative infinity, negative 3. That's all below the x-axis. And then from negative 2 3/4 to infinity. That's the answer. Yeah, it's looking for the x-intercept. Everyone have a great weekend and enjoy this